Good afternoon, YouTubers. This is part 3 of the analysis for the propeller that I put together, and I'm doing the flow simulation. In part 2, we leave this calculation. This calculation we are done with a mesh size of 4 at between 2 and 7,000 RPMs. We calculate the torque, the thrust, and RPM were converted to radian per second, so I can calculate watt. So eventually, the conclusion from that study was that watt is more important. Well, both are important because watt depend on torque as well and RPM. But eventually, watt will pick both of them, RPM and torque, just to see where we are. The idea is that I need to calculate what are the RPM for 150 watts because that's actually from the spec clearly says that we cannot go above 150 watts. So what I'm planning to do is repeat this calculation, but doing that fully automated so that the system will pick for me the proper RPM and will calculate eventually until we hit the 150 here. Certainly, you can do here in manual. You can do an interpolation and come out with the proper value that you need for 150 here, based on that 5,000 is 102, 7,000 is 286. So you can interpolate to get the 150. What are the RPM required for 150, which definitely will be above 5,000 but below 7,000. You can do that. Now, here's the story. I want to do this again. I want to repeat this, so I'm going to copy that. Copy. Let's put it here. I'm going to do some changes, but now increase the resolution to 5, just to just to see how good my numbers are. And now the RPM will be the same from 2 to 7,000. Obviously, this will come out from the study, so this has to be deleted. There's nothing going to be there. And thrust, there's nothing there. That has to come from the study. But it will be done fully automated. And let's see what happened. Again, what we are looking is for 150. I'm planning to do perhaps an optimization process. If I do an optimization, I don't have to have a table like this because the system will do sort of like a Newton-Raphson type of equation where it's looking for the target of 150 watts because that's our target. In fact, I'm going to change here. I'm going to write the word. Our target is to hit eventually 150 watt. I will say plus minus, I will say 10 watts. Like, for example, it could be between 140 minimum to 160 maximum, and you will be okay. That will, whatever RPM you come up with would be within that range. So as the lowest range, 140, as the highest, 160. So that's where you are for the target or the watts. Not like in this case that I was targeting more the torque, but I'm now more aware that the best way to do this is by targeting the watts on this motor, and that will do. So this is what we're gonna do. We're gonna set up an optimization process in SolidWorks to get this done. How we do that? First of all, we don't have that watt equation that is calculated here. You can see I need to multiply, for example, whatever is calculated on D, that's this value here. Whatever torque, I need to multiply the torque by the radians per second to get watts, and that will do. So I have here plus minus. Let me get this equal from out. So there we go. Why? Oh, it keep doing it. Well, you have to put a symbol. Let's see if we grab it now. There we go. Plus minus 10, that would be the 140 and the 160. All right, so let's go back to SolidWorks, and let's create, the first thing that I need to do is create this equation in SolidWorks. So because that will be the equation that we need to iterate about. So going back to SolidWorks, let's see where we are here. There we go. This is where we left this on part 2, and now let's work on part 3. And if you remember, I only have these two equations right now, so I need to create my what equation. So get into goals and hit here, insert equation goal, and what I need from that equation is, first of all, I need the rotating region, in particular the angular velocity, and we going to multiply that by whatever torque is calculated, and on the goal here, so I got torque here, that's multiplied by torque. So we got everything. The angular velocity, and right now is set 578 because that's the number that is there right now. And whatever torque the system will calculate, and that will do. Now let's change this to a meaningful name. Let's call this watts. That would be joule per second. Let's see if we can find the proper unit here for that. That will be power. Joule per second. Let's see where we have. We have a power spectral density. Not sure where that. Let's see. Now, I don't like that. Those units. In fact, I don't see unit of power here. Physical time, molecular mass, length, external work, energy. It's interesting. I don't see power. Heat transfer, heat transfer, heat transfer. Let's see. Heat transfer coefficient. No, that would not work. Oh well, I don't see units here. No unit then. We know it's joule per second. No big deal. So we got everything that we need. Let's set. We're gonna set that. Now I have watts. Here it is. So what's next? Next is let's prepare the system for an optimization process. How we do that? So let me, before I forget, let me change the global mesh again, and let's put this back. It was 4, so let's put it back into 5. Let's accept that. So let's go back to tools, flow simulation, solve, new parametric study. And now let's pick what we're going to be doing. We're going to be doing a goal optimization. And with that said, let's see what would be the parameter that we're going to be doing variation on it. It's going to be this rotating region, this one here. Open them up a little bit more until you find what you're looking. Angular velocity. Let's accept that. Did I got it or not? Okay. Oh, sorry. Here. There we go. Now, what is the range? The range comes from Excel. You remember, it was from about 200 to, if I go back to Excel one second, is from, I can put 209, 733, from 209 to 733. That will do. So 209 to 733. We accept that. Now, what else do I need to do? Criteria. Let's pick from the goals what we want, and we want watts. So it's gonna be this one. Let me double check on this one for 1 second. What is the target value? The target value is 150 watts, but plus minus here, plus minus. Well, let's say 10. So we accept that. Now we got everything. Now, output parameters. Let's go back here. The output will be all of them. We accept that. For the scenario, let's see what we got for the scenario. How many of these trials do we gonna run? Remember, it's kind of using a Newton-Raphson type of equation, so maybe you don't want to run this too much. I don't know, maybe about no more than 20. Within 20 runs you haven't reached the proper value of around 150, there's something weird going on. So there's nothing else that I want to do here. Look good. So how about goals? Got that. Nothing more. Looks like we got everything that we need. So let's do the run. And so the way that this is gonna work is it's gonna pick the first run. It's gonna do either the higher or the low value, and then it's gonna do the other range. And from those two ranges, it will start to interpolate eventually until it hit the 150 or so. So let's see. Let's run this and let's see what range it will start to use from the RPM values. The 733 RPM. So now it's going to target the 150, and by looking into watts, you see, if I bring this, there we go. And I forgot to add watts here. Doesn't matter. It will do the calculation. Never mind. So now this is gonna run for quite a while. Remember, I increased the mesh size to 5, from 4 to 5. That's gonna take a while. Maybe it used to take half an hour to do each individual work that I did here in Excel. Each of these one took about half an hour. So if I move to 5, it's gonna take a while now. And what is kind of nice is that SolidWorks will prepare. It's going to be here. It's going to show it's sort of like a table with the design point. Like for example, here is 733. Then it will pick another one, and you will have as many design points as required, no more than 20. So, and each one might take about an hour because I increased the resolution to 5. So we'll see. Meaning that this study might take quite a while. Imagine that if each one take an hour, and I said, about 20, so we are talking about pretty much a whole full day of number crunching on my laptop here. I hope it doesn't get too hot in the process. Nothing else to say here, just to wait. Like for example, let's back here. You can see that it's already started to crunch the first numbers, and this is going to take a while. It's just starting. Might record everything that happened here, but then on the others, I will do the regular cutoff, and because it's just take too long and waste a lot of memory and resources. So let's keep recording here. Since this is gonna take a while, I'd rather pause this on the recording and come back when there's something, when it's about to finish. Well, it looks like the first run is about to finish, and we'll see. Still cranking numbers, as you can see here, and they are in the black already, meaning that we are pretty much over with this. We're still on the the first run. I hope it finished. It said here it's about to finish, and I can see here it's pretty much estimating that it's about to be finally got completed. So now it's doing all the calculation, it's uploading the results, and we will see here that this first column It's gonna get some data there. It's gonna be updated. There we go. Now it's going to the second shot for the design plot. Number two, as you can see, it picks my numbers. The 733 and the 209 are the range. So now it clearly said here that the target value was 150, but it hits about 298. So there's an error. The difference between this and this one is this value here. So now it's gonna pick this 209 and we'll do the same. We'll take about an hour again and we'll do the calculation fully automated. So you're not touching anything. Now, so as I told you, it's gonna be preparing a table in a, sort of like an Excel table, and you're gonna get all the parameters that you need. So this is at 209, the angular velocity, and basically the idea is that it's gonna, look for this watt value here, which should be about no more than 10, because we know that from previous study. Although that was done at the mesh 4, now we are in mesh 5. We're going to continue doing this kind of study, maybe mesh 6 or 7. But as you increase the mesh, if your machine is it's kind of slow, that will take for a while. And that things need to be done, kind of overnight or something like that, because it's take way too much. So what I'm gonna do now is stop the recording, just to avoid wasting so much memory, and let it go. And as you can see, now this value here will be, as I said, no more than 10. So what's gonna happen is it's gonna start to interpolate for the proper value between 298 and 10 to hit the 150. So it's gonna put another design point, and we'll keep going until it get to the range that we want, which is 150 plus minus 10, and that not exceed 20 of this design point here. That will do. So let's stop here the recording, and let's wait. Alright, so I'm back again to see what the system is doing. It did the design point 1, design point 2. As you can see, it's less than 10. Yeah, we know that. And it was about 8 the last time I calculated this. And but that was with a low resolution. Now it interpolated the 465. It got 48, too low, so it crank it again a little bit higher to 574, and now it's doing the design point number 4. So, and that's what you see here. It's running right now. And how about the force? Kind of weird. Got a negative value here. That's kind of strange, meaning that the resolution that I'm using, which is 5, might need to be increased to 6 or 7, just to ensure the numbers start to make sense. We'll see how this looks like at the end, but definitely I need to improve something on the force here. Torque look good, makes sense. It's just the force doesn't make too much sense. I wasn't expecting this negative value. It's kind of weird. I need to check that. Let's keep going and let's see what happened. So I'm gonna stop recording and I'll be back. Alright, so as shown here, solution converge with only 4 points, end up being about 145, which is within the range of the 150, so it's okay. 574. Now, I can see something kind of weird. The force here went negative. I need to check on that. What happened there? Have to do perhaps with the criterion, so I need to check on that. But this looks great, and and the force is about 6 Newton, and the torque is a little bit higher than 0.2, is as expected for the 150, and the RPMs, or in this case the rad per second, 574. a value that is between the 733 and the 209. And it took about 2 hours for all this. Now let's finish here. And the only thing that I would like to do at this point is save these results and have it with my Excel table, kind of a properly presented. And that's basically it. Let me see. So, thinking about it, what can be run here on why the force is negative, because it should be positive. And you see the numbers here, how they looks like something's not right, and I have to check on that. And I think the problem is not, obviously it's not the optimization process, could be the mesh 5 might not be that good, but could be also that it kind of it quit the iteration at a point that it looks like it was okay, but it wasn't. So let's check on SolidWorks something which is very important, that sometimes it gives trouble, and it has to do, let's see, solve here. In solve, calculation, control options, criterion to stop goals, converge on all of them, and trouble, and trouble. It is in auto, and I think here's the problem. You have to satisfy all of them, all satisfy. That might fix the problem. Let's say okay now. Now the other thing that I want to double check is, let's add two more goals here related to the force. This is surface goal, and so let's go back here. Let's see, and let's see, insert a global goal. Let's insert one global goal that had to do with force. Let's get this better. Hard to take a look what's going on here. Let's see, that will be force in the y direction. You know, that value is the total should be very close to the other one, and that will help me to ensure that yes, the number start to make sense now. Anything else that I need to change here? Nope. So let's accept that, and let's add another force. It's going to be a surf. This is what it got, global goal, and let's add another one, but it's going to be a surface goal, but that will be normal to the surface. Let's see, normal force, this one, normal force, but then let's pick the surfaces that I'm going to be talking about. So it's going to be that one, that one, that one, that one, that one. All forces related to the blades. Oops, this not. Yeah, that looks good. So now we got all of them. Let's see. All right. Well, so I got that. Normal force on, and that's it's a surface goal. So let's accept that. Now I have here 5 goals, including the last one watts, and this is in Y, this is in Y, and this is in Y. What that really means is that these three values should be very, very close, and I'm forcing, the system will force that. And now since I upgraded the the solver here, that to ensure that all are satisfied, which include the trouble and the goal conversion, which was there, but not for the trouble. So let's cancel here. That's okay. Now, what I need to do now is just do again the motion study. I mean the motion study. what I need to do here is the optimization process. So let's go tools, flow simulation, solve, new parametric study, and change this to goal optimization. Pick the variable that is going to be changing, and this is rotating. And let's check on that, accept. And now let's change the range. This is hard to pick, so let's get this bigger. Now, this is the minimum and the maximum. Let's go back to Excel for 1 second here. It's from 209 to 733. 209, 733. So that's what we're gonna do. 209, 733. We go back to SolidWorks and fix that range. 209, 733. We accept that. Now, okay, and then criteria that will be from here. That would be watts. Let's pick that one. And so the target value is 150 plus minus 10. Let's accept that. Now, output parameters will be all of them. And CS scenarios. Maximum number of calculation. No more than 20. More than enough. And I think we are ready to go. Nothing else to do. Let's run this and let's see what happens. It's running the mesh. Now, let's add, let's see, let's close those two and let's add a new one. Select all of them and let's say okay. And there we go. And that's the first design point as we did in the past. And let's see how this looks like. It's gonna take for a while, so let's stop here. All right, after an hour running this, I see, calculate my first point at 733, watt, about 304, way too high from the 50. We kind of knew that since definitely in the past we have run this before. And but the forces, let's see, force 577, 582, and 587. The three of them very close. Makes a lot of sense now. And the torque is about 0.41, too high from the 0.2 mark. It runs also the 209, which is the lowest range on my rotation. The 209 rad per second, and so what was the about 6 the watts, way too low from what we want, and now it's doing the sort of like an interpolation for or a Newton-Raphson type calculation for the 461, and it's calculating this. So we will be back in an hour and see where we are. I hope this run about 5 or 6 points from the maximum of 20 that I have here. So I'll be back. All right, after 2 hours of number crunching, we went through the number 4, and the error is getting smaller. I think this will do about 572. And the nice thing is that the forces are getting all positive the way it's supposed to be, and they are equal, pretty much the same, if they're global or the surface forces, which is great. And I'm measuring the torque, which makes sense. at the highest RPM, I got the highest torque, and so forth, but it drops. And here you can see the watts at the different RPMs, and so about 135 at 557, but now it is in is doing an iteration at 572, and might be this one. I think this is about to finish after 2 hours. We let it go a little bit further, and I'll be back when this is done. But it looks great now. All numbers are positive the way it's supposed to be. The forces, because the wind is coming down. I mean the wind is coming down, so that's forcing the propeller up. And the force up is that the force that we are measuring, as shown here, in the global force or the surface goal, which are pretty much close to each other in Newton. So let's wait. All right, so after 4 hours, basically the system converged. I got the okay here. That looks good. And it did it in 5 runs. And so let's see how the numbers looks like. Eventually it hit to about 144, very close to the 150. You can, I mean, you can improve that, but I put, I set 150 plus minus 10, so that's okay. That's perfect. And how about the forces? The forces, as you can see now, they converge properly to the right number. In fact, you can see that the forces, the global forces in the y direction, you mean in this direction, now they make sense. So it's about 5 here, and this is surface, and this is total. And how about normal as well? Perfect. And here's the watts calculated, and so forth as my equation for applying the solver, or in this case, something similar to Newton-Raphson type of solution. But it looked great. I got everything now. The only, I would say, inconvenience, they take a lot of time. I mean, on my machine, perhaps in other machine might be faster, but in my, which is an i5 core, take a lot of time doing this. But it's great. I think that we are pretty much done. Let's see what else we can do here. Let's save this result. And let's go parametric study, and let's say this is gonna be mesh 5 for mesh 5 for propeller. And let's revise something here. Let's rep 2, and let's save that. And let's see anything else that I need to do here. Just in case something weird happen, let me copy all this. Let me see. Copy from the top. Copy and have them kind of added to an Excel table just in case I want to do something with them. They're right there. And going back to here, let's see anything else. Let's close this, and now let's see what I have here. Results on the part. It probably has. Let's see what it has. Check on rotating region. Let's see what it has here. And the definition 578. Not sure what it has here at the last loading result. Might have the old stuff, so I don't care. So that's basically it. We know that our study here is the 572, 573 RPMs, and it's about 500 grams of force, and well measured, and that will give you about 100, close to 150 watts. Well, folks, that's basically it. Next time, what I'm gonna do is go back here and do a check on the propeller, particularly on the flex here. That flex will have to be, I'm gonna edit it so that in such a way that instead of having, I will have this degree here, but here is having 0 degrees. So if I go back here for a second, and you check what I have. So this is what I'm saying. You see, it has the flex here for the what's the degree? 35 degrees, but 0 here. What we're gonna do is we want to have this flex pretty much all the way down, but perhaps instead of being 0 here, maybe like 20 or something. It still has some angle into it, so it will. We know that right here at this end, the propeller did not work as properly. So next time we will work on that. As always, thank you, thank you, thank you a lot for you watching and supporting this channel. Bye. Have a great day.